And the answer to that question is not so easy. I mean, these experiments are very hard, and it's not so clear. And then over the last couple of years, there's also another interesting connection, a connection between spin currents and heat currents. Here the idea is the following. You have these two effects known as spin-Seebeck effects and spin-Peltier effects. Spin-Seebeck is if you have a ferromagnet and you apply a heat current to this ferromagnet, does this also imply the heat current that goes through your sample, is it also spin polarized? Is it also a spin current that comes with the heat current? And the answer is probably yes, and I'll show you some examples on the next slide. The other question is, if you have a spin current, does this also generate a heat current at the same time? And that's known as spin-Peltier effects. And nobody knows yet, and more on that also on the next slide. And then there's another interesting aspect of spin that is not very well appreciated. I mean, spin does not only carry a net magnetic moment with it, but there's also a net angular momentum associated with it, a mechanical angular momentum. And we know this because of the one experiment that Einstein did, with the help of a very capable experimentalist, De Haas. Essentially what they did is they took a magnetic material and changed the magnetization, and they saw how the magnet turns as a response of changing the magnetization, which immediately shows that there is actually an angular momentum associated with the magnetization. And there was another guy, Barnett, who was much less famous, but in fact, before these guys did their experiments, a couple of months before, published his results where he saw how magnetization changes when you rotate the magnet. So this is so what it means is if you have a flow of spin current, of pure spin current, it also there's a flow of angular momentum associated with it, mechanical angular momentum. And it turns out this flow of angular momentum is actually measurable, and I'll show you some examples. So let me here first give you some ideas about this connection between spin currents and heat currents, and this is known now as spin current electronics. So in spin-Seebeck effects, what you do is you take a ferromagnet, you apply a heat current, so you heat this up a little more than this end, so you have a heat current going through here, and then at the end you put a piece of platinum on top of it. You know? And why is that? Well, so if you have a heat current here, and if there's a spin current associated with it, if this spin current goes into the platinum, we know what it does. It generates a transverse voltage. And the voltage should be opposite at this end versus this end, because here the spin current goes out and here the spin current goes in. And that's indeed what people measure. If you take permalloy